Hamburg is the ideal location for doing air transport research. We have a strong ecosystem with OEMs, with MRO, the airport, but also the Port of Hamburg as application and use case for AAM, Advanced Air Mobility Concepts, and the politic of the city of Hamburg itself in its role to support the innovation landscape through its supportive cluster policies, very valuable and appreciated here. And that makes it easy to interconnect research institutions like DLR and industry.
Hamburg Aviation Green.
Welcome to another episode of Hamburg Aviation Green, the podcast about the people, projects and technologies shaping a climate-friendly future for aviation right here in Hamburg. I'm Caroline Oxley.
And I'm Angus Bagent, and we're here to talk today about the efforts that have been underway for the last few years to reduce climate impact of flying by modifying aircraft routes without major detours or additional costs. And that's exactly the kind of solution that our guest today, Alexander Lau, has been working on. He's acting head of the Department of Flight Operations Concepts at the Institute of Air Transport at the German Aerospace Center here in Hamburg. Welcome, Alexander.
It's great to be here. Thanks for having me.
You're most welcome.
Alex, let's start with you. You've been at DLR for 16 years now.
Correct.
What's driving you personally, and what's the mission of your institute?
Personal driving is basically doing research in aviation and doing this research in a good manner, of course, and doing it detailed and consistent. And our basically new institute in DLR here is developing sustainable solutions for individual mobility in the long term. So we are doing research on the complex interrelationships of air transport, therefore doing market forecast, creating them, looking onto the air transport system from the economic point of view also, and also simulating flight and fleet operations. We have more than 60 employees in total in Hamburg and in Cologne, and all these employees design and assess air transport as part of a broader transportation system. And the Institute therefore integrates ecological, economic, technological and social aspects, and we see ourselves as main contact for politics and industry.
But you just mentioned that you're the newest of the three institutes of the DLR in Hamburg. Is that right?
That's correct, yeah. But we came up from a fusion of two institutions which already existed in DLR, and therefore we have two locations, as said, Hamburg and Cologne. And we've been funded in November 2024. Official opening took place there, but our institute exists already since spring 2024.
Your institute is here in Hamburg. What role does the city play in your work?
Hamburg is the ideal location for doing air transport research. We have a strong ecosystem with OEMs, with MRO, the airport, but also the Port of Hamburg as application and use case for AAM, Advanced Air Mobility Concepts. And the politic of the city of Hamburg itself in its role to support the innovation landscape through its supportive cluster policies, very valuable and appreciated here. And that makes it easy to interconnect research institutions like DLR and industry.
Alexander, so your institute brings together different perspectives on the air transport system, the economic analysis on the one hand, the flight operations. Why is it important for sustainable aviation to bring these various perspectives together?
Because sustainable and competitiveness is two things which belong together. Sustainability and economics have to be seen together, and therefore DLR decided to fund an institute which is not looking into the technology dimension of air transport, but is also covering economic aspects. We have 4 departments. Air Transport Development Department is therefore doing market forecasts. They are doing fleet and infrastructure trends. The Department of Air Transport Economics is looking and assessing into technology from the economic point of view, but also is creating policies for technology integration. The Department of Transport Management is looking into business models, specifically of airlines and airspace users, but also of airports. And the Department of Flight Operations Concepts, the department which I'm responsible for, is creating new ways of flying, is creating innovative procedures and concepts.
So that means your team operates right at the intersection of these different areas, like technology, environmental science, aviation practice.
Indeed.
And what exactly does it mean when you say you're making flight routes more climate friendly?
Yeah, that's a good question. Actually, that is one of the main questions of my department. Since we are looking into innovation, we're looking into innovative flight procedures. And those procedures, for example, can be to reshape a flight trajectory. So the way an aircraft is planning or is able to fly, to reshape that in order to reduce CO2 emissions, but also so-called non-CO2 emissions like methane, ozone. But there's one thing which is called contrails, you know them, when looking into the skies. They are beautiful, but they are maybe a little bit harmful too, because they have an impact on the radiative forcing of our atmosphere. This is something which we really do a lot of research in, and therefore those areas and those airspaces where those contrails may form need to be mitigated by just fly around those areas. It's not it's quite a complex task, but we are doing this task in order to come up with atmospheric science and transportation science in one way of doing it, and then also, of course, collaborating with the industry together in bringing this into reality.
You just said contrails may have a negative effect on climate. Does that mean there's still a robust discussion going on during
Indeed,
science?
there is a discussion going on, but we are quite sure that contrails have a warming effect at nighttime. But they can have a cooling effect also. So it's always a question of, if you're looking into one flight, for example, flying at night, there might be another effect than flying at the daytime. And that gets even more complex when we're looking at total fleets or big fleets of flights. So there's an ongoing discourse about the climate impact of contrails at the moment, but we are sure we need to do something.
So when you were just talking about trajectories, so just to get into the weeds on this just a little bit, what aspects of the trajectories are we talking about? What parameters are you actually looking at?
Good question. Yeah, the trajectory basically is a four-dimensional flight path. You can all imagine you start taxiing at the airport, then you depart from the airport, fly, and then approach another airport. So the basic thing on describing a trajectory is on the lateral and on the vertical plane. The lateral plane is given by longitude and latitude. The vertical plane is given by altitude, but then there is also a time dimension. So for each and every point in time, we need to know where's the aircraft, in which state is the aircraft, and one very important question, how is flight performance, let's say, behaving at the moment? Is the aircraft able to fly that trajectory? And that whole flight performance dimension is something which we are able to model in DLR in a very detailed manner. And from that point of view, the vertical profile is very important. So to say, how steep is the approach, or what climb performance can an aircraft fly?
So you're matching also what the aircraft can actually do with the atmospheric conditions and so on. Bring those two parts together.
Indeed.
Yeah.
And that's very important, because the atmospheric conditions have a strong impact on the flight itself. Of course, it's also related to safety critical things. The aircraft shall not fly directly into a thunderstorm, for example, but you may think about, flying around a thunderstorm costs money because the trajectory will be longer afterwards. Then think about flying above a thunderstorm, may work, but it's also safety critical because there's heavy turbulence above. And therefore, each and every flight, also the pilots have to decide. But to support pilots in taking these decisions very dynamically is the task of DLR. And we are developing systems to do so.
So it sounds simple and complicated at the same time, because our flight routes can be adapted right now. You don't need to build new planes like for other technologies. But how realistic is it to change flight routes in the very busy airspace that we have?
Yeah, first of all, it is always a combination of technologies. So to say, I'm giving you an example. You have, for example, sustainable aviation fuels, which are not that climate intensive, let's say, in its impact potential. We hope that it is that way. In that sense, it may be possible to not have these major detours around climate-sensitive areas. This is a subject of actual research we're doing in DLR. But the most important point here is not only to do the research itself, it is to transport the research results into the industry. And therefore, at the moment, we have a very good project which is called DCALT. It's the demonstrator project for climate and environmentally compatible air transport. It is funded by the Aviation Research Program of Germany called LUFO, initiated by the German Ministry of Economic Affairs and Climate Action. And in this project, we look into the realization of climate-friendly trajectory from the beginning, meaning months before in the flight planning until the flight termination itself. And the main question we ask ourselves, together with a lot of partners like Deutsche Lufthansa, PACE, Lufthansa System, German Weather Service, DFS, and so on, we have the question in how accurate have, for example, meteorological data to be, because in the use case of contrails, we need to have very specific meteorological states that these contrails are forming persistently. And this is regarding temperature and humidity, and you have to predict that before the flight so that you know what kind of airspaces do you have to reroute or do you have to mitigate. That is one topic we are looking at. In the other sense, if you reshape a trajectory, it is also, in most of the cases, aligned to an increased fuel consumption. And therefore, there's always the trade-off of that increased CO2 emission due to the increased fuel consumption on the one side, and on the other side, the effect of climate impact mitigation due to fly around the contrail sensitive regions. This is something which you can do on the mission level for each and every flight, but also do on the fleet level for thousands or even millions of flights. And you can imagine you have to come up with the computation infrastructure, with the conceptualization to do so. And a third thing is, of course, imagine you are rerouting a flight. What is the controller and how is the controller on the ground from ATC being impacted? What can happen is that a lot of flights are going to be shifted into other airspaces. We call them ATC sectors. So one sector is overcrowded by traffic and the other sector is quite empty for a long period of time. And this is not what is desired. And since we are answering all these questions, we have been able in the project to initiate the so-called 100 flights trial, where German airlines are testing in real operations whether persistent contrails can be avoided through climate-optimized flight routing. And initial satellite-based analysis is quite promising, but there are quite some questions to be answered in that sense.
Sounds absolutely fascinating. Very complex, of course, the overall system that you're dealing with. But how can some of the expertise and some of these methods, how can they also be used for other questions when you're looking at air transport?
Indeed, yes, they can. And we are, of course, looking into sustainability question, but we're also looking into efficiency. And we have a project which is even looking into safety. This project is called Measure. It's a good example for another context than climate impact mitigation. And in that project, together with the German Weather Service, which is leading the project, and the Enviscope company, and in a subcontract with Airbus Defence and Space, we are developing a remotely piloted aircraft system, which is basically a fixed-wing drone, which we are going to equip with measurement and measuring equipment to fly into contaminated airspaces. Now, you may ask, what is a contaminated airspace? We had that one time back in the year 2010 when the volcano Eyjafjallajökull erupted.
You can pronounce it.
Thank you very much. I looked at that word quite a long time. No, it erupted, and we had a situation back then where we didn't really know how to cope with that situation. In the end, DLR, with its aircraft fleet, went into the air and did some in-flight or so-called in-situ measurements. But now we are developing that drone which can fly in there without a pilot on board, of course, due to safety reasons. And our task as the Institute of Air Transport of DLR is to shape and to design the optimal measuring trajectory. You have two options. Whether you fly into that airspace and you fly up a grid. This is okay, but it takes quite some energy from the drone. Basically, these trajectories are too long. And therefore, we are coming up with a system, including kriging, for example, which is a geostatistic approach to only identify those points which have to be measured in that contaminated airspace, because what we have as a basis from DWD, German Weather Service, is a dispersion prediction of the contamination itself. It is a good prediction, but it needs to be validated anyhow. And therefore, based on that prediction, we know the important points, and then we fly in there with an optimal and most efficient trajectory.
That sounds very promising. So you've talked a lot about potential in the last two projects. What, in your view, is still holding back the breakthrough for projects like this?
Yeah. When it's coming to climate impact mitigation, I think one of the most important points is to understand uncertainties in that sense, because we have to take, and airlines have to take decisions which cost money. And now we are back in economics. And therefore, we have to continue investigating in dealing with these uncertainties, but also mitigating the uncertainties in terms of mitigating the climate impact. These uncertainties are originated from weather forecasting. They are originated also from climate impact mitigation, because you can choose different climate metrics for that, for example. But it also has technological sources, like, for example, the emission quantification is also related to uncertainties somehow. But there is more. We also, like everybody today, has to use and utilize advanced algorithm. We have to make use and see what's coming up with artificial intelligence, of course. But it's easy said. Artificial intelligence needs a lot of data to train this. And the data is always very important for research. And we are on a good way, but we have to keep on the pace to make, for example, historic traffic data, trajectory data available for research to finding the right answers. And as a third point, this is rather a human point, let's say. You talked about the complexity, and so everybody somehow understands these things a little bit different. And therefore, we have really talked to each other and have to ensure a common understanding of what we want to achieve, what is the metrics, what is the potential technology. And that is one of the takeaways of the DCALT projects, that we need time to talk to each other and to understand the dedicated problems of individual stakeholders.
So just zooming out from that perspective just for a second, so what other impulses can should we be bringing into this space to try and perhaps advance some of this research, maybe make it more turn it into some kind of, into practical systems? What do you think the next steps should be?
Yeah, good question. I think the next steps are basically continuing research in climate impact mitigation in terms of combining operational approaches on how to fly aircraft with new technologies. We talked about that already, but those new technologies have to be assessed in a wider framework. And this is very important, so to say, as a decision support also for the political side on where to invest in future. And DLR is therefore providing assessment skills and assessment frameworks in its projects together with the industry to make this assessment understandable and the results also on a visual basis being worked up. And on the political side, I think it's important to create a political framework which intensifies the implementation of new innovative processes. And that is important due to bring together sustainability and competitiveness in one research framework and think that together, basically.
Alexander, thank you so much for your time and sharing some of your expertise around this very complicated subject, but one that's so crucial for the overall environmental impact of flying looking forward. So thank you so much.
Thank you too, Angus. It was a pleasure to be here.
And thank you also for sharing your time with us with our podcast. And we'll be back soon for more in-depth interviews with engineers, researchers, business people shaping the future of sustainable aviation right here in Hamburg.
Follow us, like us, give us a review on the platform of your choice. We'd love to hear feedback from you. We have a special email address for that. It's podcast@hamburg-aviation.com.
Thank you very much.